So today is our last lecture, lecture 4 in the series of this short statistics course. And what we'll discuss in today's lecture, I'll show you. We'll see that in the upcoming slides shortly. But before that, as usual, I would request you all to recite Surah Fatiha for Ali Murtaza Zaidi. Now, our today's topic is correlation analysis. What we'll discuss today is correlation analysis and the regression modeling. How do we develop the regression models, and then what are the different tests that we do to see whether our models, whether our variables are really effective or not. So we begin with correlation analysis. The first thing is that what is correlation analysis and why do we do it? So for example, if you have one dependent variable and then you collect, like, let's say 10 independent variables based on your literature review, based on your intuition, and based on some other information, you have this understanding that your dependent variable is affected by 10 different independent variables. However, at some point you have to shortlist those. You may not, but it's always better that you do. You find out those variables, those independent variables that are really significantly influencing your dependent variables, so that you select those few and discard others. And if you want to add more, you can add more, like bring more independent variables, collect more data about the independent variables, and bring that to develop the model. This is one thing. The other thing is that correlation, sometimes you do not need to develop the model. You just show the correlation between the dependent variable and the independent variable. Now, what is correlation analysis? Correlation analysis determines the strength of relationship between dependent variable and independent variables. So, for example, if we have the speed data, and we want to know what are the different independent variables which are really influencing the speeds of vehicles on a roadway. We know that it's posted speed limit, we know that is the number of traffic signals that we have, we know it's the traffic volume. So we conduct a correlation analysis to see how significant that relationship is in your data set. That is called correlation analysis. It correlates. It tells you the strength of the relationship between your dependent and independent variables, and it could be between independent variables as well. What is the factor, what is the value that tells you the strength of the relationship? It's this value R, which we call coefficient of correlation. Coefficient of correlation, we'll see shortly, I'll show you those numbers as well. It indicates the strength of relationship, and with each coefficient of correlation, there is associated a sign, a positive sign or a negative sign. Now, that positive sign, if there is a positive sign, or if a coefficient of correlation is positive between a dependent variable and an independent variable, then it means that there is a positive relationship between the two variables, which means when the independent variable increases, the dependent variable increases as well. However, in case of a negative sign, it means that as the independent variable increases, the dependent variable decreases. For example, again going back to our speed data or our speed example, if on a roadway, if the posted speed is high, then the vehicles will go on higher speed. Hello? Our voice is not coming? Okay, what's the problem? Is it coming now? Okay. So should I start again, or should I continue where I was? Should I start again? Okay. So I was discussing correlation analysis. What correlation analysis is about? Okay. Thank you. So we were discussing what the positive correlation analysis is and what the negative correlation analysis is, and what does this mean. So the coefficient of correlation, which is the R, it could be positive, it could be negative. The positive means that as the independent variable increases, the dependent variable increases as well. So for example, that the speed, in case of the speed data set, if we posted the speed of the speed limits that are posted on the roadway, if they are higher, then the vehicles will go with higher speed. That shows a positive relationship between the speed limits that are posted on the roadway and the speeds of the vehicle. However, if the number of traffic signals increases on the roadway, then the speeds of the vehicle or the vehicles slow down. This shows a negative correlation between the number of traffic signals and the speeds of the vehicle. As the number of traffic signal increases on a roadway, the speed of the vehicle decreases. There could be a very significant relationship between these two. However, it is negative. So negative and positive, they are just signs. They just show you what is the trend, whether it's going, whether it's increasing or whether it's decreasing, but it does not mean that the coefficient is weak or it's very strong. Only the number tells you. The sign just shows you which way the relationship is going. Is it increasing the independent variable? Would it increase the dependent variable as well, or vice versa? It just shows you the way or the sign or in the direction a relationship goes. However, it does not tell you whether the relationship is strong or weak. It's only the value of R that tells you. The value of R ranges between 0 and 1. Now, if there is a 0 coefficient of correlation, which means there is no relationship between the two variables. Not at all. However, if it is 1, then it means the two variables have a very strong, a very significant relationship. So usually in our practical world, we take that anything which is more than 0.5, it's a better relationship, it's a good relationship. We consider those variables, those independent variables, as being effective in determining the dependent variable, or those independent variables are influencing the dependent variable, and if the coefficient of correlationship is greater than 0.5. Anything between, like, let's say if it's 0.1, 0.2, then depending upon the problem or the data set you have, but those numbers are considered to be weak. So for example, now, I'll show you the example in my next slide. So correlation analysis can be conducted between dependent and independent variables, and between independent variables as well. Now, independent variables can also be highly correlated with each other. For example, let's take an again, I would refer back to the speed data set. So for all those roadways that have higher posted speed, the number of traffic signals are lower on those roadways, because the high-speed roadways have less signals. So this is like having the number of signals and the what is the speed limit. These two variables are kind of correlated with each other. So there could be a correlation between a dependent variable and an independent variable, and between the independent variables as well. Now, in my next slide, I have a table here. This is when we do the correlation analysis. This is the kind of, using SPSS, this is the kind of table that we get. So we have the dependent and independent variables on row, and then in a row, and then we have over here in the column as well. What does this show is that, see, it's a cross classification. When we conduct the correlation analysis, it shows all these numbers, they are the coefficient of correlation. And see here the signs, the negative sign here, If there isn't any sign, which means it's positive. So all these are R's. These values are R values. Now, so for this, the first line over here in this table, it shows the independent variable. The independent variable, which is the speed, and the dependent variables, all these: the posted speed, lane width, what is the width of the median, how many driveways are there, and what is the length of the segment, or what is the length of the roadway between two signals. So all these, beginning here, posted speed, two segment length, these are independent variables, and this is a dependent variable. Now, why do we have this kind of a table? So that we can cross-classify. Over here, using this column, you can see the relationship between posted speed, the dependent variable, and all the independent variable, which means that how posted speed is related with the lane width. Yes. Well, it's just a way of showing the significance. So if double asterisk over here is 0.65, which means that this relationship is significant. As I said, that anything above 0.5, we take it as a significant, or it's like that the relationship between the two variables is strong. Okay. The question was that what do the asterisk mean here? So what do the double asterisk mean here? So you see these double asterisks here, these double stars here. SPSS, it gives you an indication that when there are with all these numbers, when there's a double star, which means the relationship of the correlation coefficient, or R, is significant, or the relationship between the independent variable and the dependent variable is strong. So as I mentioned, that anything above 0.5 is a good relationship. So see, with 0.58, 0.65, 0.71, we have double star. So double star simply indicates that the strength of the relationship between the variables. Understood? Is it clear? Okay. So if I read this first line, it says that the speed of the vehicle is very highly correlated with the posted speed here. We are seeing a 1 star here. I'm not much sure why did this. Maybe this is some that might be. I'm not sure about it. I have to go and see why it is. But what I know is that double static means that it's a significant relationship. However, it shows that the posted speed and the speed of the vehicles are very highly correlated with the speeds that are posted on the roadway, and the strength or the number of that shows that relationship is 0.97. This is almost close to 1, and the sign with this is positive sign, which means as the posted speed on the roadway increases, the speeds of the vehicle increase as well. Then comes the lane width, like the width of the lanes on which the vehicles are traveling. The lane width is in this case, for this sample, for this data set, or like for this sample, in the way the data was collected, it shows that the lane width are not as strongly related with the speeds of the vehicles. However, the width of the medians, they are somehow significantly or strongly related with the speeds of the vehicles. But again, see over here, with all these variables, the sign is positive. So as the speed limit which is posted on a roadway increases, the speeds of the vehicle increase as well, because motorists, when the motorists see the high speed posted on the roadway, they'll drive fast. Similarly, lane width, as we have the more wider lanes, the motorists or the drivers will feel more comfortable driving on those roadways, and they will drive fast. And likewise, the median, if the separation between the two